Okay, we have finished trigonometry, which was our measurement and geometry part for Spiral 3. So now we are back to linear relations for our third trip through. So we started with algebra, then we did working with lines and the equational line and all that. Now we're going to kind of combine the two. We're going to actually be working with linear relations, but we're going to be doing it what's called algebraically. So we're going to be using algebra skills to work with it rather than the graphs. So we're going to kind of ease into that by going back and looking at extending our algebra skills to work with situations where we might have more than one variable, or we have a formula that we have to rearrange. And it's not just kind of rearranging stuff for the heck of it anymore. There's actually a purpose. And we're going to look at some examples of important equations that you can use in various jobs and things. So the first thing we need to be able to do is something called substitution. So substitution is just how we use the equation to do what we want it to do. Like when we had a linear relationship, y equals mx plus b, if I knew the x value, I could substitute it into the equation where x was to find the y that goes with it. So we're going to do something like that. So suppose we have a linear relationship right here, and I want to find it what the y value is when x is 6. So we're going to use our algebra skills to begin with. We'll rewrite the equation just like we do in algebra. So y is going to sit there and mind its own business because nothing's happening there yet. And then m comes next, and we see m is the slope. Slope is negative 1/2. So we're going to put negative 1/2 where the m was. And you'll see I put it in brackets, and it's a good habit to always put this kind of thing in brackets so we don't get mixed up whether we're adding or subtracting or multiplying, especially when we get to exponents. It's really important. So get into the habit of doing your substitution with brackets. Then we have our x value, and we see, so we have an x value of 6. So in brackets, we're going to put a 6. And then, we're running out of colors. Let's go orange. And then we've got our y-intercept, which the y-intercept is 4. So plus 4. Now for this one, the brackets aren't doing anything because it's only adding and subtracting, but that's okay. I just remember that. These brackets aren't really doing anything because it's not multiplying or anything, but there's no negative signs. But it was still good to be in the habit of writing them anyway. And now we actually do the math. So y is equal to, well, 1/2 times 6 would be 3. Half of 6 is 3. And it's 1 is negative, 1 is not, so my answer is negative. So negative 3 plus 4. Right? I just do one step at a time. Order of operations, multiplication before addition. So I'm using my Bedmiss skills. Multiplication, division are before addition, subtraction. And then finally, y is equal to negative 3 plus 4 is 1. So that means when x is equal to 6, y is equal to 1. And if we were doing our graphing, that would mean there would be a point where x is 6 and y is 1. So you'd have like sort of a point over there. We're not graphing right now, but just let's keep in mind when we are doing linear relationships, we are still thinking about this sort of two-dimensional space. So moving on, let's practice that substitution skill. So first, we have the area is equal to, or sorry, this one's not an area question. This is an annuity question, an investment question. We'll get to some of this later, but anyway, A is equal to P times 1 plus RT. And I want to find that when P is 1,000, R is 0.04, and T is 8. So I just substitute everything in. So A stays where it is, the equals stays lined up, just like in our algebra. P is 1,000. And then we have 1 plus r, 0.04, times t, and t is 8. So we have to use Bedmiss. So brackets first. So we have to do our brackets first, and in the brackets, multiplication, so this part happens before addition. Those Bedmas skills coming back. So the 1000 will mind its own business, the 1 will mind its own business, because all I'm doing is this part here, 0.04 times 8, 0.32. And then the next one, well, we have to do the brackets again. This bracket, there's nothing going on. The second one, I have addition, so I can clear that up. 1000 times 1.32. And then we'll just grab our calculator and figure that value out. So this one's an easy one. It is just 1,320 because we multiplied by a power of 10, right? So it goes over 1, 2, 3 spots. Or you can use your calculator. Either one is fine. So pause the video, take a minute, try solving the second one. D equals VT plus 1/2 AT squared. And remember to use your Bedmas. When you have a whole bunch of things going on, you have to do them in order. So brackets first, simplify what's in the brackets. So it doesn't mean you multiply bracket by something first, but you have to simplify what's in the brackets as much as you can. Then exponents. Then division or multiplication in order from left to right. And finally, addition and subtraction from left to right. And if there's complicated stuff in brackets, you do Bedmas inside the brackets as well. So pause the video, try this one, and then unpause it to take it up. So D is going to be equal to V, which is 50, times T, which is 6, plus 1/2 A, which is -5. See, that's why it's really important to have that bracket, because otherwise it would look like a half minus 5, but there's a half times -5. So really, really important to have those brackets. And then times T squared. So T is 6, and then all of T is squared. So don't put your bracket, don't put your exponent, don't put your exponent in here, because if there's a negative, you won't be squaring the negative, and that'll cause a problem. Make sure it's outside, because the whole bracket with the 6 is our T value, and all of T is squared. So now we have Bedmas. Step 1, brackets. Well, I don't have anything to do in the brackets. I have brackets, but they're all just numbers. They're all just a simple number. There's no addition, subtracted, multiplying, dividing, so they are already simple, so we're done with brackets. Then we do exponents. So I've got an exponent at the end. Everything else stays the same. 50 times 6 plus 1/2 times -5, and then 6 squared is 36. And then we can be a little bit lazy. So we're done exponents, so then we have division, multiplication in order. So I've got a lot of multiplication. Since I have this plus kind of separating the two halves, and I do plus last, I can do this multiplication and all that multiplication in the same step, but only because they're separated by this plus. So 50 times 6 is 300. 1/2 times 36 would be 18, times 5 would be 90, but it's negative. Whoops. So not plus. We have minus 90. I'm just going to double check on my calculator that my mental math is correct. 5 times 36 divided by 2, 90. Good. And then we just do the addition subtraction last, which is 210. Perfect. So that's substitution. You literally just take the number. So over on this first one, we knew R was 0.04, so we just take that number and we replace the R with the number, because they're the same, they're equal. So I can replace them and it doesn't wreck anything. It doesn't change anything. I'm just writing it differently. So what's the other thing we might have to do? Well, here's the algebra. That was just Bedmas skills. This is the algebra. Sometimes a formula is in the wrong order. So I have y equals mx plus b. Oh, I have a typo there. or I have them in the wrong order. That's okay. I'll fix that for next time. So y equals mx plus b is our equation for a line, which is great. But what if I knew the y value and I wanted the x value instead? That means I have to do what's called isolate x, which means get x on one side of the equation by itself. So we're like solving for x. That's another way to write it. Solve for x. So currently x is here, not all by itself. I want it by itself. So we use our algebra skills. We move everything away from x by doing the opposite. So this is a two-step algebra problem then. There's no numbers, so it looks a little scarier than what we did earlier because it's not numbers I'm moving, but it's letters. But remember, in math, letters are numbers. We just don't know what value they have yet. So they behave the exact same way. I can do adding and subtracting and multiplying, dividing with letters because they are just numbers. It's the exact same kind of thing. So I'm going to have to get rid of the m, and I'm going to get rid of the b. So there's two ways to think about the order here. I like going sort of like the onion, peel the onion approach, go outside in. So this is further away, so I have to get rid of it first. Another way to look at it is you can do bedmiss in reverse. So rather than bedmiss, we have Sam Deb. So you do it in reverse. So when you're doing algebra, only for algebra, first you do the adding, subtracting, then the multiplying, dividing, and just like before, left to right, then the exponents, and then the brackets. So you can do Sam Deb if you don't like the outside in approach. So let's try that for this one here. So I have a multiplying, m is multiplying by x, b is adding to x. I look at my Sam Deb, I do adding, subtracting first. So I'm going to get rid of this plus b first, because I do adding, subtracting first. So I do a minus b, and a minus b and a plus b add to 0, so it's gone. And whatever I do to one side, I do to the other. So now on this side, I have y minus b, and on the other side, I have mx, and that's all, because the plus b is now gone. And now I go back to my Sam Deb. I have no adding, subtracting, so I do multiplying, dividing next. So I'll get rid of this m that's multiplying by my x. How do I get rid of it? I do the opposite. The opposite of multiplying is dividing. M divided by m is just 1, so that's gone. Whatever I do to one side, I have to do to the other. And it goes under everything. You can't just divide y by m or b by m. It has to be everything on that side. So that means y minus b over m is equal to x. And that is our formula that isolates x or solves for x. So if I had a value, if I said what x value goes with y, I could just plug in the y and the b and the m, do that calculation, and that would give me my x value. So let's try that with a couple other equations as well. So here's an equation for simple interest. We'll look at this in more detail in a minute. I is equal to PRT, and I want to isolate it for r. So I'm going to get r all by itself. So look at my Sam Deb. I need to get rid of things in the opposite order. So P is multiplying and T is multiplying. They're both multiplying by my R because they're touching. Anything in math that's touching is multiplying. So there's no adding, subtracting. And then it's multiplying, dividing, and we do that left to right. So let's get rid of the P first. So P is multiplying. I'll divide by P, and whatever I do to one side, I do to the other. P divided by P is 1. So we have I divided by P is equal to RT. And then I have to get rid of the T, so I have to divide by T. Whatever I do to one side, I have to do to the other, and it just goes in the bottom. If there's already a fraction on that side, we don't do this. Whoops. We don't do this. We don't want fractions on fractions. That's a mess. So if there's already a fraction over there, it'll just sneak right in there. It'll join the bottom because I was dividing. Bottom of the fraction is the same as dividing. So I over pt is equal to r. And that would be our equation that solves for r. Try for this one here. This is actually a temperature one. If you want the temperature in Celsius, you take the temperature in Fahrenheit minus 32 and then divide by 1.8. We're going to rearrange it to solve for Fahrenheit instead. So pause it, try that yourself, and then unpause it, and I'll show you. You can check your answer. Okay, so we have f over here. We want to get it by itself. So we have a subtract and we have a divide. And if we're not careful, we're going to think we get rid of this subtract first, right? Because SAMDEB, we do subtracting and adding first. This is another one of those little tricky math spots, so make sure we're paying attention. Remember, if there's a fraction part here, if we're dividing that whole thing by 1.8, then we have to treat it like there's brackets on the top, because we have to do that before we can divide. So that means I've got brackets and I've got division. So if I look at my SAMDEB, I do division before I do brackets. So I have to get rid of that 1.8 first. So it's in the denominator, it's dividing, so I'll multiply by 1.8 to get rid of it. And I will multiply this side by 1.8. So I have 1.8, whoops, that's not what I meant. 1.8c is equal to f minus 32. And I don't need the brackets anymore because there's no dividing, there's nothing happening to them. Then I have just subtraction. So I do that next. So I will add 32 to get rid of that. So I have to add 32 to this side. So we have 18c plus 32, or sorry, 1.8c plus 32 is equal to f. And that is our answer there. So that's it for skills. We're not learning anything beyond that. We're just going to do a couple specific cases where this comes up. So one of these, especially for word problems, because the goal is to actually apply stuff to real life. One case where this kind of formula manipulation comes a lot is when we're dealing with distance, speed, and time. So if you want to calculate a distance, we multiply the speed and time together. So d is distance, s is speed, t is time. And distance is equal to speed times time. Easy enough. But sometimes we'll need to find the speed or the time, so we need to be able to rearrange the equation. So in this case, if I wanted s by itself, I would divide both sides by t. So s is equal to d over t. And if I want t by itself, I'd have to divide both sides by s. So t is equal to d over s. So we can rearrange them really quick, and we'll do that in the question below. I just wanted to kind of show what it looked like. So Earth and Mars are 150 million kilometers apart. If a probe leaves Earth for Mars and flies at 26,000 kilometers per hour, how long will it take? So we have to rearrange to isolate for t, and then substitute, and then solve. So it's all coming together now. So we have d is equal to st. I want t by itself, so I have to get rid of that s. Whatever I do to one side, I do to the other. So t is equal to d over s. And I just changed which side they were on because I like solving when the variable's on the left. If you just did d over s equals t, that works too. And now we have our substitution. So if t is equal to d over s, well, they're this far apart. That's a distance. So we plug that into our formula. T is equal to, our d value is 150 million. And then our speed is right here, 26,000 kilometers per hour. You can tell it's speed because it's kilometers per hour. Speed is a rate. So we plug that in, 26,000 1,000. And then you run through that through your calculator, and what do you get? I guess I don't have to give you any time because you can just pause the video to do it yourself, but oh well, that's what I did anyway. So I get 576.9, and then I need units. I have to do units to give an actual answer to this. So I have to look to the question. So distance was kilometers, speed was kilometers per hour, so time has to be in the same units as we were using. So this, in this case, it will be hours. It doesn't mean time is always in hours. You have to look at what the other variables are using and make sure it matches up. Last one. Oh, why does that show I'm off by a 0? Oh, because I did 15 million. Yep. So this decimal is one place over. My apologies. 5,769.23 hours. Okay. My apologies. Another one where you're going to see a lot. You're going to see a lot, because finance is part of the grade 11 curriculum, is something called simple interest. So this is the simplest way you invest money. You put money in the bank and you earn some more. So his here, P is the principal, which is how much you invested. So it's all right here if you need it. So that's the amount of money you put into the bank, essentially. It doesn't have to be a bank, but you know, often is. R is the interest rate. So usually they have an annual interest rate of like 4%, for example. But we have to do it as a decimal. So if it gives you as a percent, you have to convert that to a decimal. So remember, percent means out of 100. So 4% means 4 out of 100, 0.04. So you would have to use it as a decimal. And then finally, T is how long you've invested it in years, specifically in years. So if you might have to change that one too. If you invested something for 6 months, for example, that would be 0.5 years. So T would be 0.5 because it's how many years you have it invested for. So just like up above, we have our nice formula I equals PRT, but we might have to rearrange it if we want to solve for anything other than the amount of interest that we earned. I guess just for a minute. So interest literally just means when you invest money, when you put money into an investment in the bank, which your savings account is technically an investment, but it doesn't earn very much money. But if you put it into something like a GIC or the stock market, mutual funds, technically crypto would be an investment, although it's a riskier one than a lot of the other ones. The interest is simply how much that money accumulates, how much it earns in 1 year. If you're ever at the point where you need to buy a car or a house or something, quite often you'll borrow money from the bank instead, and then instead of earning interest, you will have to pay interest to the bank. So it works either way. From this example here, you can do both. But in this specific example, we have Damon. He deposits $500 into a savings account. So this is what he does at the beginning. So this is his principal. It earns 0.5% simple interest per year. So this is a percentage. I'll have to change it to a decimal. And then we want to know how long will it take. So we're going to be solving for T, the time. Whoops, I forgot to label my R. To earn $120 in interest. So that's interest, that's our I value. So it says rearrange to isolate for T, and then substitute and solve. So I is equal to PRT, and we rearrange this on the other side for R, the same idea, and we can actually do it in one step if we see that everything's just multiplying. So if I want T by itself, well, P and R are multiplying, so I can divide by P and R. and that'll undo each other. Whatever I do to one side, I do to the other. So t is equal to I over PR. And R is a decimal, remember. So therefore, let's move over here to do my substitution. T is equal to I, which I was 120, divided by P, which is $500, times R, which 0.05, oops, making all sorts of typos today. 0.5%, percent means divide by 100, so that's 0.005 as a decimal, 0.005. So pause here, calculate the value, and we'll make sure you got it right. I'll do it on 120 divided by 500, and then, oh yeah, how do we type this into our calculator? That's always a good one for when we have multiply in the denominator. I would type it into your calculator as 120 divided by 500, because it's in the denominator, divided by 0.005. And that's the easiest way for me. Everything on the bottom, you divide by. So 120 divided by 500 divided by 0.005 gives me 48. So what does 48 mean? How did I get 48? No, 48 is right. I must have had a typo on my sheet. 48 years. So we remember T is in years, so it would take 48 years to just make $120, which is not very, very good. And the reason for that is this is a really, really bad interest rate. We'll see if we even have time to talk about this stuff later. But 0.5% is really low. That's the type of interest rate you'd see on like your checking account, maybe your savings account, because they're not designed to make you money. They're just designed to like hold your money. So if you ever want to invest, you want to find something that earns a lot more than 0.5%. And that's it for the note. There's lots of practice problems for you here. Question 2, you'll see we're car traveling at a speed with a time and how far. So this is a DST, a distance, speed, time question. I think all the other ones are pretty kind of clearly labeled. We have simple interest. And then we got a big tricky one at the end. If you get finished early, you can take a shot at that one. That's it for day 1, and we'll see you again tomorrow for day 2.